So this is problem 60, my page 4, problem 60 on 363. So we're given the function f of x equals negative 0.8x squared plus 3.2x and plus 6. Of course, f of 0 is 6, 0 comma 6 is the y-intercept. It's very clear. So everything is in feet, the height is in feet, the horizontal distance is in feet, where it was thrown, fine. What is the maximum height of the ball, and how far from where it was thrown does this occur? What am I really asked to find? I'm asked what is the maximum height and where does it occur? What am I really asked to determine? What does it say? It's a subtle way of saying find what? If it says find the maximum height, it's a subtle way of asking us to find what? So let's go back to what we just graphed, because it's a quadratic function. What did I say was the most important point that I always have to start with?
The vertex?
Indeed. The vertex, indeed. So how do I find the vertex for this function? Excellent. Thank you, Chris.
Negative b over 2a.
Very good. So the x-coordinate is negative b over 2a, negative. Make sure that this is in descending order, because if it gives, it's a trick question if you want, if it gives it to us all sorts of way, no. Rearrange it in descending order first. So negative b, can anyone give us b to us?
3.2.
Very good. And 2 times a has to be a negative number. 2 times 0.8 is negative 1.6. How do I divide this? There is one decimal point. So first of all, x cannot be negative. So of course, negative with negative will cancel each other out. So it's 32 over 16, which is 2. And this is 2 feet. So this is where it occurs. This is the axis of symmetry, if you want. In other words, it occurs at 2 feet from where we launched it. But how do I determine the height? They want us to find the height.
You will have to plug in 2 to the equation.
Very good. And you know what I like to do? I hope you like this too, because this is a very good method. Punch in the graphing calculator to your function, because you may need to evaluate it for other things. So why not have it ready? 0.8x squared, and then plus 3.2x, and then plus 6. You have the function. We plug in 2, and we get 9.2 right away. Don't forget the measurement unit. This is feet. So this is the maximum height. So the maximum height is 9.2 feet, and that means this situation. So this is the 6 feet. It reaches the maximum and then eventually will hit the ground. And this is 2 feet, 2 feet. And this is the 9.2 feet, because this is the vertex, is at 2 and the height is 9.2. Okay, moving on. So how far does the ball travel horizontally before hitting the ground? They want this now. How far away from the height of 6 feet, right? This is where we are standing. okay? And we're throwing it up in the air and eventually it will hit the ground. So we know that this is 2 feet, but we want to determine this. What point is this for the function? Because once I know what it is, then I know how to determine it. What point is this for this function?
And x-intercept.
Very good. Exactly. So this is, the other one will be here, but who cares? Nobody. But we do care about this one, the positive solution. The other one, obviously, it's a symmetric graph with respect to the axis of symmetry. So we should hit here, but nobody cares about this one. We only care about this, but we will find both. So we have to set y equal to 0. Negative 0.8 x squared plus 3.2x plus 6 equals 0. Please refuse to ever solve an equation with a negative leading coefficient. Please refuse. Multiply both sides by negative 1. 0.8x squared minus 3.2x minus 6 equals 0. You don't have to do anything because you are allowed, you have a calculator, you are allowed to use the feature in the graphing calculator. If your calculator doesn't have this feature, please borrow a calculator from the testing center for the duration of your test. Click on apps, click on 9. The degree is 2. Yes, move on, enter. 0.8, negative 3.2, and negative 6. And then click. So one solution is, as expected, negative 1.39. Nobody cares about this in feet. And the other one is 5.39 feet. So this we don't care. So this is 2, and this is 5.39, and it makes sense. And this is the horizontal distance traveled by the ball. I do this. Gets to the maximum, and then it hits the ground. And this is the horizontal distance traveled during this process, traveled by the ball. What is the maximum height? 9.2. Where do I launch it from? The y-intercept, 6 feet. Let's see what else they want. Graph the function. Thank you. You're too late. We already did. Any questions on this problem? If we're given a quadratic function and we're asked to find the maximum or the minimum, this is the key, the vertex. So in this case, the vertex has coordinates 2, 9.2. X, which is negative b over 2a, and f of that number. The key in the quadratic function is always the vertex and, of course, the x and y intercepts. Good. Can we consider for now that the quadratic function is done? With graph and word problems? Do you think we need more?
Maybe not this time, but next class.
Okay.
I would like to go over it again.
Okay, but remember you have to watch the videos and you have to redo the problems we did in class. This one problem is not enough and another problem will not be enough. Please.
Okay, I will.
I'm begging everyone to do that. Good. What do we move on to?
We go to 2.
Good. So you want to graph a cubic or you want to graph a 4th degree? You can give me any function. So let's work on any function you would like, a cubic function, which is degree 3, or a 4th degree function.
Can we do the cubic function?
Yes. Can anyone give us a cubic function? Any? When you said cubic function, this is what goes to my mind immediately. Either from negative infinity to positive infinity, or from positive infinity to negative infinity. And a maximum number, possible number of turns is 2. It doesn't have to turn twice because the degree is 3. So the moment you said cubic, this is what goes to my mind immediately. It's either this or this, and the maximum number of turns is 2. Good. So I'm going to share my screen and just go to the page 380. Good. So let's choose a cubic function and work on it. And one thing that I don't want to forget and to mention this intermediate value theorem. Which I didn't initially. It's extremely simple. You'll see in a moment. Anyone would like to choose a cubic function? Anyone, please.
Can we do 19?
Let's see, 19. Yes, it is a cubic function. Excellent. Good. So 19, we have f of x equals 5x cubed plus. So 19 is indeed a cubic function. I just wanted to say, it says here only use the leading coefficient test to determine the end behavior. Because the leading coefficient is positive, this will be the end behavior. I'm not saying that we cannot graph this function. I'm just saying that it's not a very friendly function. We can graph it. So it's up to you. As you see, all the other ones are a little bit, easy to factor, easy to find the zeros. This is a different story. We can. So 5x cubed plus 7x squared minus x plus 9, you'll see what happens. So let's take a look for a moment. Okay, I didn't need to go all the way back, but that's okay. So this is degree 3. I want to find the zeros. I have a hunch that they're terrible. So 5, 7, -1, and 9. And I expect something terrible. Marok. What I meant to say, nothing nice. Okay. So look at these two. It's a very good example just to see what's happening. So when you look at these two, look at 0.28, whatever, minus 0.91, and 0.28 plus 0.91. So see what's happening here? These are imaginary solutions. Look at this I. So the function only crosses once. It does not cross 3 times because these two solutions are imaginary. So the function will only cross at roughly -2. So when we create the table at -2 and then 0, it's approximately -2, approximately -2. And at 0 is 9. And the end behavior is this, which is -infinity to infinity. And it crosses, of course, because it's multiplicity 1. So the function will look like this. Coming from, so this is not something that is easy in college algebra to work with. Because you will see if you need to take math 230, we have a lot of different tools that we cannot present in Math 037, 137 to graph something like this, which we do not have today in 037, 137, but we do have in Math 230. So it crosses at -2. So the function is coming from -infinity. At 0 is 9, 2, 4, 6, 8, okay, 9. So we will not know, and I'll show you with the graph, but we have to use a graphing calculator. We will not know what the function is doing. Probably is doing this. That's why this function is not listed in the set of exercises for graphing. So you're not going to have something like this to graph. But since we are discussing it for a moment, I just would like now to look at the graph, and you'll see what happens. And then I promise I'll shut up for 10 minutes, I promise. Okay, so in y equals, if I put this function in, which is 5x cubed, again, not to worry about such a function, plus 7x squared. That's why they are only asking for the end behavior. They're not asking for anything else because they can't in this class. Okay, so I'm going to change the viewing window a little bit because I want to see a little bit more than 10 for y maximum. So I'm going to say 15 or 16. Okay. So, okay, nobody would have known this with the information that we have in this class, that it will reach a maximum and then come back and turn. It doesn't even turn at 9. It turns to the right-hand side. So this is not a function that we can graph in this class. That's the reason why, again, it only says use the leading coefficient test to determine the end behavior. So these are the ones that are determined, if necessary, use the maximum, and so on and so forth, where we should be asked to graph. Yes, these are okay. Okay, so I think it's about time for me to shut up for 10 minutes. So let's stop here and then we'll continue.